record. So let's have a look at the stack, but using the Python code. Okay. So you know, it's abstract data type. There is a stack, there is a queue, there is a linked list, and there is a binary tree. We have to take all of this. So stack, we always say it like that. So stack is a LIFO. You know what is a LIFO?
No.
Last in, first out. Last in.
Okay.
So it is an array that we keep putting in values inside it, but when we want to take something out of it, we take the last thing that we already input inside the array. So let's have a look. So let's have a look here. So this is a stack. Okay, it's just a kind of array, but the last thing we enter is the first thing that we take it out. So imagine that you have an array that can carry 5 values from 0 to 4. Okay, and then you inserted all the empty spaces here. Let me see. I don't know why this guy is not. Yeah. So imagine that we already keyed in a few values here. Okay, here 4, and then here 5. So this happens to be in our case the last thing that we entered inside our stack. So if we want to say I want to take something out of the stack, okay, so I will call a function. This function is called pop, P-O-P, and then I will be taking out the last thing that I entered inside the array, which is 5 in our case. Okay, and once I pop it out, I will totally remove it from here, and then I will update a few things. Okay, so this is what is mean by a LIFO, last in, first out. Okay, last in, first out. So yeah. Okay. Normally, so okay. Now one more thing. When we deal with Python, of course, is slightly different from pseudocode. But if you notice, actually, this line is actually declared in pseudocode, not in Python. So this line is in pseudocode. Okay. So he's defining an array from 0 to 4 of strings. So he'll put strings inside. So let us go to the previous slide, and then we will see that he already say push. So push means I push something inside the array. Pop means I take something out of the array. So okay, so he said push Taha, push Ali, push Amjad, push Bano, and then pop. Pop out means he will take out something from the array. He will take out the last thing that he entered to the array. So he will push out Bano. He pop out something one more. This means that he is going to take out this one also. So both will be taken out because of these two pops. Okay, and then he will push something in again. Push means that he will put inside the array this Qasim. Okay, so far so good. Joy, can you hear me? Can you follow me?
Sir.
Okay.
Yeah.
Okay, so the code that we use for push is actually okay. So it's a kind of a method or procedure. It's not a function, so it means that it does not return a value. So in our case, the first thing he defined is the names. Names is an array that carry 5 items from 0 to 4. So he first defined it with empty strings, okay? And then he implements something called a stack pointer. Okay, so a stack pointer is a pointer that always carry the last position that we use to enter a value. Okay, so previously when we dealt with array, we never used that before. we never have to care what was the last thing that we input inside the array. But in our case, to be able to use this stack and to always keep, we want to always keep the last position we entered a value. So we have to use a stack pointer. The first thing that we initialize the stack pointer will be 0. So it will be always pointing to 0 at the start. Okay. So if we push, this means that okay, so if we push here, let's see. Okay, first we will check, as you see, stack pointer variable is defined outside the method push. Okay, so to be able to use it inside the method, we have to use a keyword called global, because the stack pointer variable is actually not defined inside the method or the procedure. Okay. Okay. After this, we have if statement. So the array have a size. You cannot enter something beyond the size of the array, because that will cause an exception. Okay. So we have to check the size of the array first. How we check the size? In our case, the one that always keep a track of what was entered inside the array, in our case, is called the stack pointer. So we know that we define an array of strings from 0 to 4, which means that it will carry 5 items. Okay. So we check if the stack pointer is bigger than 4. This means that the stack is full. Okay. If it is not, this means that there is a way that we are able to push something inside the array. So here we are pushing something inside the array. So we use the stack pointer, okay, as an index, and we push the value that is passed as a parameter here inside this specific position inside the value. Okay. So the stack pointer in our case, is actually incremented here. Why? Because next time we want to insert something inside the array or even pop something out, we have to depend on the position of the stack pointer. Okay, is that clear?
Yeah.
Okay, we can move to the next. So again, let me share with you again. Yeah, here. So you know, okay, as you see here, the stack pointer will be always pointing to the position that we last inserted something. The stack pointer will start always with 0 here. So it will be always pointing to 0. Once we insert something, we push something here, then it will be incremented. It will be pointing to here. Okay. And then we insert something here, then the stack pointer will increment it by saying stack pointer plus 1. This point is clear, right?
Yeah.
Okay. Okay. So now we check how can we pop something out of the array. Pop means that we remove something out of the array or of the stack. So again, we have to depend on the stack pointer. Stack pointer is defined outside both function pop and push. So we have to use the global keyword. Okay. So again, we check if the stack pointer is 0, it means the stack is still empty. You never enter anything because that is the initial position or value of the stack pointer, which is 0. Okay. So if it is not, then we will execute that line. So we will subtract 1 from stack pointer, and then we will print whatever inside the position inside the array. So let's say the stack pointer is not 0. It means that, let's say it have 2 items inside. So this means that the stack pointer is pointing to 2. Okay. So if we want to pop something out, means so we subtract 1 from the stack pointer. So because stack pointer is 2, so it means that the stack pointer now equal 1. And then because you remember the array is starting from 0. So 0, 1, it means that there is 2 items inside. Okay, so now the stack pointer value is 1. Okay, so we will get whatever inside the array at index 1. Is that clear to you? Clear to you or not? Okay, great. Okay, so let's see. Actually, this is something that you can see in the exam because it happened to be in one of the previous exams. So a program needs to use a stack data structure. The stack can store up to 10 integer elements. Okay. A 1D array stack data is used to store the stack globally. The global variable stack pointer points to the next available space in the stack and is initialized to 0. Write a program code to declare the array and pointer as global data structures. Initialize the pointer to 0. So let us see how he implements that. So as we said before, there is no declaration inside Python. So he always asks you to use a declaration, but you have to use it with a comment sign. Okay, so it's the same way that you declare arrays inside pseudocode. So declare stack data. He asks you to create a variable called stack data that is an array of 1D array that is carrying some variables, integer variables from 10 variables. So it's from 0 to 9. Is that clear to you?
Yeah.
Okay, and then we declare the stack pointer. Again, there is no declaration in Python, so we have to use the comment sign like that. Okay, and then it is of an integer variable. So we declare both as globals here, and then we start to initialize. This is an array, so we have to initialize the array the way we do it like that. So it will contain all zeros at initialization. Okay, the stack pointer also will have 0, will be initialized to 0. Should we move to the next?
So what does it mean by global at the front of stack data and stack pointer?
Okay, global means it will be available to all the function or procedures that we will use later. Because, okay, so inside, okay, the variables, any variable that you use in Python have 2 scopes. It's a local scope or a global scope. A local scope means that you define a variable inside a function, and then you use it inside the function, and outside the function nobody knows about it. This is the local scope. So
Okay.
once the function finish, whatever inside the variable that you define inside the function is totally forgotten and nobody knows about it. You cannot access it anymore. But a global variable will retain its value between functions. So you call one function on it, and then you can call any other function and can access all the information inside that variable because it's global to everybody. Everybody can see it. Is that clear to you?
Yeah.
So there is 2 scopes, as we said, local and global. Okay, we move to the next. Okay. So as we said at the previous lesson, we tried to move slightly faster, but of course, to be able to adjust your exact speed, you have to either slow me down or make me move a bit slightly faster. So are we fine in the way that we are doing it now, or should we move slightly slower?
Yeah, it's okay.
It's okay, good. Okay, so we need to write a procedure to output all the 10 elements of the stack and the value of the stack pointer. So he asked me to output means that we need to print whatever inside the stack. So somehow we need to use a for loop to be able to print whatever inside the stack. That's how we can see what is inside the stack. It's a print statement. Okay. So okay, we define a procedure because it doesn't return anything, okay? And then to be able to use the two variables that we defined earlier, the two variables is called stack data, which is an array, and stack pointer, which is an integer. To be able to access them, because they are globally defined to everybody, we use the keyword global. So, okay, now first we print the stack pointer, okay? It's easy, it's just an integer, so you just normal print statement. But now to be able to print the stack data, we have to use an array, a for loop, okay? So a for loop range from 0 to 10, and then we are able to print all the array content of stack data, of the variable stack data. Is that clear to you?
Yeah.
Okay, good. We move to the next. So he wants us to write a function push that takes an integer as a parameter, okay, and returns false if the stack is full. If the stack is not full, it puts the parameter value on the stack, updates the relevant pointer, and returns true. So that will be a function, as you see here, because it will return something, okay? So write the program code that defines the function push. So let's have a look here. So again, the push, we have seen some definition of the function push, but then again, he might ask you for certain addition or certain features that you add to the code itself. Okay, so that's at the first time when we see an array of strings at the start, if you can remember. Okay, when we started here, our first array, it was array of strings. And then we see how we create a push, but to push what? We was pushing actually strings, because names here is actually an array of strings. But in the exam, he can ask you to use an array of strings, array of integers. It doesn't matter. If you understand the concept, then it should work with everything. So here, we first compare. If the stack pointer is bigger than 9, means, oh, okay, we already know the array is from 0 to 9. It have 10 elements, 10 integer elements, okay? So we check this one first. If the stack pointer is pointing to the end of the stack, if we have a stack like that, okay, and we're starting from 0, and that is position 9 here, and the stack pointer is pointing, is bigger than 9, is bigger than here. So this means that the stack is full. So we have to return false. We cannot insert anything more on the stack. Okay. So if it is not, then we execute this code, which is insert whatever you want, you have as a parameter here, number, inside the stack pointer here. So if the stack pointer in our case, let's say it's 2, so we come to position 2 here, and then we start to insert whatever inside here. Let's say it's 10. Let's say its number is 10. So we come here, we insert 10. This is what this line is doing. Okay. After this, we increment the stack pointer. So the stack pointer will be pointing to 3 now. Is that clear?
Yeah.
So that next time you call the push with a value, it will be inserting here, whatever you want to insert here. Okay. Good. Okay. So now edit the main. He asked me again to do some edits. He edit the main program to test push function. The main program needs to allow the user to enter 11 numbers and attempt to add these to the stack. Output an appropriate message when a number is added to the stack. Output an appropriate message when a number is not added to the stack, as it is if it is full. Output the contents of the stack after attempting to add all the 11 numbers. So we have a stack that only can carry from 0 to 9. It means that it's 10 elements. So it means that it cannot carry 11 elements or 11 numbers. Okay, so that is actually a protection for us. Okay, so let's have a look how we can implement that. Okay, so we make a loop here, a for loop from 0 to 11, because he will attempt to enter how to say, more than what the stack can carry, but he will ask the user to enter that. So he will print to the screen, enter a number. Okay, and because we created our array, this array of integers, so we can only insert integers to the array. So we have to do this integer conversion. Means if you enter a number with a decimal, it will automatically convert it to a decimal, to a number, a normal integer without a decimal. It will remove the decimal point, and then it will store that inside the value. And then we will do this if statement. So we will try to do a push, and we will try to put the values that the user have inputted, and we stored it in value. If it returns true, that it will mean that it was successfully added. If it doesn't, it means the stack is full. Can we look back here? So, okay, we have to stop now, and we have to enter again.
Okay.
Okay.